For any help regarding biology assignment help, visit www.nursingassignmenthelp.com. Email info@nursingassignmenthelp.com. Call us at +1 678 648 4277. Directions. This take-home exam is to be completed without help from any other individual except Drs. Dedden, Tannenbaum, Hoffmaster, or Lim. This includes help from other students, whether or not they are taking 20.201, faculty, people via the internet, and so on. You are permitted to use your books, class notes, library resources, internet information resources, and other inanimate materials. Please prepare your answers to all questions as a single PDF document labeled with your name. Please prepare your answers using word processing software and insert either digitized hand-drawn graphics or computer-generated graphics. The answers should not exceed the stipulated length per question. Please submit your answers by email to all of the following email addresses before class starts at 1:30 p.m. on November 7. Late exams, without prior approval, will not be accepted. Profs. Dedden, Tannenbaum, and Hoffmaster considered the depth and breadth of the answers in addition to the correctness of the answers. This was a take-home exam with a significant time element for writing thoughtful, well-argued answers. If you did not rationalize your answer, then we subtracted points. Question 1. A. Hypoamaracillin 2 has just been developed, structure below. It is more potent than hypoamaracillin, structure in your lecture notes, in terms of the concentration in vitro that gives. Nursingassignmenthelp.com. 1. What are the safety considerations for your drug? 2. Examine the metabolic pathways to determine whether there are one or more reactive intermediates that could lead to toxicity. Are there other potential mechanisms for consideration of safety? A 50% inhibition of its target, but you have been given the job of predicting solely on the basis of its structure whether it would be a safer drug. Since the original hypoamaracillin was isolated from soil in the Brazilian rainforest, you are not certain of its pharmacophore, but both molecules have obvious toxicophores. Speculate on what you think is the pharmacophore and the toxicophores in this potential drug and back up your analysis with specific ideas. B. For the drug you have been assigned, you have already been asked to work out the metabolic pathways. Now you are to describe the following. Question 2. HA dose, mg plasma elimination T1/2, HR. Root AUC, IG/L*H. 25 10 4 750 10.2 oral 709.9 IM 125 plus 250 milligrams 14.24 1070 ibuprofen 14.5 oral 1025 plus 250 milligrams 10 4 740 compound X 10 oral 220. Nursingassignmenthelp.com. Administered 25 milligrams doses and obtained a VD of 0.08 L/kg, which is similar to the rat and mouse studies. In addition, you performed comparative bioavailability studies with HA alone and in combination with ibuprofen, IB. HA causes headaches in 90% of patients, and another experimental compound, EX, that was designed to prevent HA metabolism, table shown above. Use these data to answer the following questions. 1.5 page max for all answers. At point 1, calculate the bioavailability of HA for the oral and IM routes of administration. Describe possible mechanisms that could explain the different AUC values for HA administered alone. What additional information would you need to establish the mechanisms? The oral route is nearly as efficient as the 4 route for uptake of HA into the circulation. 93% of the drug enters the general circulation from the oral route. However, only 13% of HA enters the general circulation following an IM injection. This could mean that HA is unstable when injected into muscle, example, metabolism. Similar to first-pass metabolism in the liver, the drug never makes it out of the muscle due to rapid metabolism. or that it does not enter the blood capillaries well when injected into muscle tissue, with a depot effect. NursingAssignmentHelp.com. A. You have been hired as the Chief of ADME at ACME Pharmaceuticals. Your predecessor characterized the pharmacokinetics of a new antibiotic, hypoamaricillin, HA, in mice and rats and obtained a plasma elimination half-life of 14 hours and a volume of distribution, VD, of 0.08 L/kg with a dose of 0.1 mg per kilogram in both rodent models. Your job is to define the pharmacokinetics in humans in the first phase I clinical trial for this drug candidate. In your first human studies, It is not possible that the rate of removal of HA from muscle is so slow that the time frame of our PK analysis missed the bulk of the drug movement into the circulation, since the plasma half-life is the same for all routes of administration. If the rate of movement of HA from muscle to tissue was slower than the routes of elimination from plasma, then the plasma half-life would equal the rate of loss of drug from the muscle. We would need to 1. Rate of metabolism of HA in the muscle and 2. Kinetics and extent of urinary or fecal excretion of the drug and its metabolites. A.2. Calculate the plasma elimination rate constants for the fore and oral routes in the presence of ibuprofen. Describe possible mechanisms that would account for the changes in both plasma elimination rates and the AUC values caused by co-administration of ibuprofen. What additional information would you need to establish the mechanisms? 7.5 klim equals 0.693/T1/2, so for oral route, klim equals 0.693/14.2 HR equals 0.049 HR1, and for fore route, klim equals 0.693/14.5 HR equals 0.048 HR1. The co-administration of ibuprofen has decreased the rate of elimination of HA from plasma, which results in a proportional increase in the AUC, the area under the plasma concentration time curve. Several mechanisms could account for this behavior, including ibuprofen-mediated inhibition of HA metabolism, competition for enzymes, or ibuprofen-induced downregulation of metabolic enzymes, competition for elimination transporters in liver or kidney, or ibuprofen-induced downregulation of transporters, and enhanced reuptake from the kidney nephron following filtration at the glomerulus. Competition for plasma protein binding sites, with increased free HA concentration in plasma, would not account for the changes in elimination kinetics since the rate of elimination of HA would not change in this case. Information needed includes evidence for transporters and drug metabolic pathways, along with the routes of elimination. NursingAssignmentHelp.com. A.3. Describe possible mechanisms that would account for the changes in the AUC values caused by co-administration of compound X in light of the lack of change in the plasma elimination kinetics. What additional information would you need to establish the mechanisms? The statement that compound X was designed to interfere with HA metabolism is a red herring, something to mislead you. If this was the case, then the design did not work. Co-administration of compound X by either route does not affect the plasma elimination rate of HA. However, while the AUC for HA does not change when it is co-administered with compound X by the fore route, there is a significant decrease in the AUC when both drugs are administered by the oral route. Since the rate of plasma elimination is not affected by compound X or route of administration, then we must assume that hepatic metabolism and other elimination mechanisms are unaffected by compound X. The fact that compound X reduces the AUC of HA when administered by the oral route suggests that compound X interferes with the uptake of HA from the intestines. It enhances first-pass